So good evening again everyone. This is going to be the important lecture and very simple state formula. You can get your 4 marks at least. Okay, what we were going into this lecture, because in the previous lecture what we learned, there are two types of you can say properties of a light: particle nature and a wave nature. So few phenomena you cannot understand, you cannot prove on the basis of a particle nature. So this particular effect also we are going to learn only, and we are going to explain, or we are going to understand only on the basis of wave theory of, you can say, light. Clear everyone? So in this particular lecture we were going to discuss in a great detail about the photoelectric effect. That is your first you can say page. So what is photoelectric effect? Photoelectric effect is very easy. Whenever on any particular particle, like the process on which the solar cell is working on, that is basically a photoelectric effect. So experimentally, what is a photoelectric effect? Whenever a light is going to hit on any particular material, so light have an energy in the form of waves. We're going to understand what is E equals to h mu, E equals to hc by lambda. So that energy going to be subdivided into two main things. The first thing, that energy is going to make the free electron, which is valence electron. What is a valence electron? You guys know this thing very well. This is your atom. So in this particular atom, this is your, you can say, the nucleus, and the just a minute, the the electron in the outermost shell, right? The electron in the outermost shell is known as a valence electron. So obviously that electron is far away from the nucleus, far away from the, you can say, or you can say, attractive force of a nucleus. So it is going to be get free even after we apply a very short amount of light energy, or a very short amount of energy. So the moment any particular light, suppose on a you can say atom scale, that light wave is going to hit in this way. Clear? So this energy is going to be subdivided into two parts. The first part is, it is going to be known as a wave function, or you can say threshold thing, or you can say threshold make this particular electron free. So once this particular electron gets free, once this electron is get free, so it starts moving. And we know whenever any particular electron start moving, so that create a what? Electric effect, or you can say electricity. So this is the whole soul process, and this process is basically known as photoelectric effect. On this basis, we develop this particular kind of semiconductor and so to make or to convert light energy into electrical energy. But the basis of all the thing is photoelectric effect. Is this clear, everyone? This is the main line. This is the whole soul thing. But the relevant properties, how it is going to be, what it is. Okay, what is a light particle, photon? What are the properties of a photon? What is the equation in great detail? What are the, you can say, this threshold frequency relation with the light intensity? What is the kinetic energy, and how you can rewrite this kinetic energy in different forms? So you can going to see in this lecture. Is this clear? The main one thing is photoelectric effect. Okay, so let's see that what a photoelectric effect, or in reflection thing, the dual nature of matter and the dual nature of radiation. We were were groundbreaking physics notions. Scientists discovered one of the nature's best kept secret around the turns of the 20th century. Means when the 20th century is going to be turned around, it is going to be complete. So we find the wave particle duality. What does this mean? A light ray is behaving, or any particular charged particle is behaving as a wave or as well as particle. That is the dual nature that shows, or the dual nature of a matter or radiation. Matter is basically matter, and radiation basically the light or intensity of light. So everything is made up of waves and particles. Is this clear? So what we learn, the dual nature of light is not only you can say fixed till light only. It is going to be extended to each particular particle. The matter, because matter is made up of what? Matter is made up of electron, proton, neutron. So even the charged particle is going to be moved with this you can say appropriate amount of light, speed of light. So they are going to show the same effect, and the same effect is, but what it is in general, the same effect is bit of dual nature of you can say matter. Sometimes that particular particle itself is behaving like you can say wave. Whenever we going into the quantum realm means in the quantum world. Quantum world means very very short. If we are going to talk about the atomic particle, and these atomic particle starts moving with the speed of light, so that is going to be turned around the wave nature. I mean, these particular properties we are going to learn on the basis of wave nature. But when we are going to talk about atoms, or you can say the combination of atoms, molecules and compounds, then we treat this particle, you can say, then we treat this particular subatomic particle as a particle in general. Is this clear what I am saying right now? So not only radiation, but radiation as well as matters also shows the dual nature. And what is a dual nature? Wave particle duality. Means it behave as a wave as well, it behave as a particle as well. So what is a photon? Photon is basically a light particle. Okay. It is a light particle, or you can say quanta of light. You can hear this term also. Quanta of light. What does it mean? Quanta of light means, as we know, as we listen, this charge Q equals to NE, right? So E is the smallest charge particle, or you can say E is the smallest charge present in any particular subatomic particle, or you can say on anywhere. So every particular charge we are going to represent with the with this particular electronic charge. In a same sense, when light is going to be represented, so we are going to talk about photons. So the intensity or the amplitude contains this n number of quanta, or you can say n number of light particle, and that light particle is basically a photon. Is this clear, everyone? Clear now? In the same sense, a photon is smallest discrete. Discrete means that is can be represented in the number. Smallest discrete amount of electromagnetic energy, also known as quantum. What I write quanta in a, you can say, plural sense. It is the fundamental unit of all light. So the light particle is behaving as a quantum, or you can say a single particle is known as a photon, and that is quanta of light. Photons are continuously in motion and travel at a constant speed of this. This is basically c, and that is going to be turned around 2.9983 into 10 to the power 8 meter per second to all observes in vacuum. The speed of light indicated by the letter c. Every photon has a specific quantity of energy and momentum. The photon's energy is provided by Planck's constant h. The value of Planck constant is, okay, I can rewrite this thing. The value of Planck constant is 6.626 into 10 to the power minus 34 joule second. Okay, and V is the frequency of light. So the momentum of photon is given by h by lambda. What does it mean? This is a de Broglie hypothesis, and you can say we are going to see the uncertainty principle also. But how it is going to be related to this? As you can see, momentum we can represent into the form of energy also. Momentum P equals to 2m ke. Ke basically kinetic energy. Is this clear? How we can get it? That is very simple. Kinetic energy is nothing but P square upon 2m. Clear, everyone? Clear na? Is this what I'm saying? And H is basically joule per second. Okay. So it is going to be joule per second, and it is going to be what? Lambda. Lambda is meter. So putting the value of this, or you can say from the simplest thing, as we know, momentum P equals to meter per second. Is this clear? So that is the unit of this. H is basically joule into meter, or sorry, joule per second. Joule per second, or it is going to be joule second. Wait. The momentum of a photon is E by C. E is going to be hc by lambda, and that is going to be, wait, H is basically joule second, right? And that is going to be, P is going to be meter. Okay, joule, when we are going to put the value of joule, that is M, what it is, force, Newton per second, and force is going to be ML 2T minus 2, okay, and that is second. So putting all this thing, and okay, this one is length ml2, and that is going to be lambda L. So m is going to be cancelled out for single moment, or you can say for smallest mass, we can take m equals to this. So this is going to be cancelled, and due to this second writing. Okay. So I mean, using the unit system, we can see that we have a SI unit of momentum is meter per second, right? And when we're going to put this H, which is joule per second, and lambda, so both of the things going to represent the same thing. H by lambda is nothing but joule into second into lambda is basically length. So putting this length to the power 2, taking mass as a 1 for 1 kilogram, or you can say for unit mass, and that is going to be T minus 2 and T to the power 1 and then L. So basically this is going to be LT minus 1, basically meter per second. Clear everyone? So from the unit system, we can, for a unit mass, we can say that momentum is going to be H by lambda, simply. Momentum of a photon, or basically photon taken as a unit mass, or you can say quanta, because it represents the one unit for a light particle, or you can say it is also known as a light particle. So we can take a unit mass. Okay, is this clear? Is this clear, everyone? Okay. This. Yeah. So now there are the properties of photons. Let's discuss these properties of photons. So solar panels used to generate power. Metal combination in these panels allow power to generated from a wide variety of wavelengths. Basically, the photons, or you can say the photons, can convert it into the energy, and that energy can convert it into the electric energy. This is basically the solar panel all about this. Sensors of motion and position. A photoelectric material is placed in front of a UV and IR LED. In this case, light is switched on when an object is placed between the LED and the sensors, and the electronic circuit recognizes a change in potential difference. What does it stand for? Basically, all the sensors, and you can say this LED light emitting diode, or our new Android TVs, basically do the function on this particular principle. We turn on the light, and the moment we turn on the light, this electric energy is going to be converted into the radiation or light energy, and these small LED is going to be glow up, and that is how we can see the minute change of potential difference. The manner we can change, you can say the light, or we can turn on or off the switch. The moment potential difference is going to be changed, then entirely this energy is going to be converted into the light energy, and due to this we can find, or we can set a limit. If the limit is going to be crossed, so we are going to find the, we are going to use as a sensor. It is going to be glow, or it is going to be give us a siren. So the sensor for motion, and you can say for position, and for, you can say, this LED system, and you can say Android smart TV system, that is working on this particular principle of photons. Okay, clear now? Means reverse process of photon. Then light sensors, basically such as those found in smartphones, allow for automatic screen brightness adjustment in response to ambient light. This is due to the fact that quantity currently created by the photoelectric effect is proportional to the amount of light that strikes the sensors. Means the function in our phone or in our smartwatches, whenever it is going to change according to the ambient light. So this is the material, a kind of a photoelectric material. So the amount of light is going to be changed, and accordingly that stored energy is going to be glow to give you the full, you can say, screen brightness. In digital cameras can detect and record light because they have photoelectric sensors and respond to the different colors of light. So all these basically things are working on the principle of photoelectric effect as well as on the photon system, and these are the basic different properties of photon. Is this clear, everyone? Is this clear, beta? Okay. Now in burglar alarms, photoelectric cells are utilized. These are the important applications. Photo multipliers used to detect low light levels in the early days of television. It was used in video camera tubes. This phenomenon is used in night vision systems. The photoelectric effect is also used in the research of nuclear reactions because released electrons tend to carry specific energy that is in distinct of the atomic source. It is used in the chemical study of materials. So this photoelectric effect is going to be used in so different way or so many n number of ways. Moving ahead, the quantity of photons crossing an unit area, or you can say crossing an area per unit time increases, light intensity increases. It has no effect on the radiation's energy. What does it mean? Suppose on a particular unit area, this is your particular unit area. On this particular unit area, if n number, or you can say if 100 photons is going to be hit on this unit area, so that particular thing is known as a intensity or the radiation pressure on this particular unit area. Is this clear? So the more intensity, the more photons is going to strike on a unit area, that is known as a or represented as a intensity. Electrical and magnetic fields have no effect on a photon. It has no electric charge. So obviously if it is has a neutral particle, so that is not going to detected by any particular method which is containing electric and magnetic field. A photon is a massless, and that is how basically we can you can say remove the mass term, because a photon itself, it is a massless particle, very minute mass. It's steadily constructed particle. When the radiation is emitted or absorbed, photons can be generated or destroyed. Okay, so these are the basic properties of photons, but the important one is this massless, and this one is important, and this one itself is important. Clear everyone? Is this clear, beta? This Vishwanath and Yajira, please beta turn on your cameras also. Okay. Then during a photo electron collision, the whole energy and momentum are conserved. Obviously, energy and momentum conservation is going to be the principal application in all the senses. A photon is incapable of decay on its own, so it is not going to decay. A photon's energy can be transferred when it interacts with other particles. In contrast to electrons, which have a spin of half, a photon has a spin of 1. Okay, that is you can say a little bit more deeper sense. Every particular, what is the meaning of a spin? As you know, electron can revolve on in a two senses. Okay, as you can see, just a minute, I'm going to explain you what does it mean. In an atom, this is your atom, and this one is your going to be nucleus. Okay, so in an atom, if we are going to talk about the electron, so this electron is going to do the two kinds of motion. One is in this way, okay, clockwise or anti-clockwise around this particular nucleus, and another kind of a motion is this way. Okay, not this color because this is gold, yeah. And that is going to be, it is going to be moved on its axis also, but it is not complete full revolution, half of the in this way and then half of in this way. So that is the meaning of spin S half. In half. Is this clear? Is this clear, everyone? Means you can understand on the basis of the earth rotation, like earth is rotating around the sun in this way, and it is going to rotate on its axis also, right? In the same way, electrons are going to be rotate around a nucleus also, and that is going to be rotate on its axis, but it is not completely half this. So that is why positive and negative. You can see this thing in higher classes, electron, or you can say the electron capture is treated as a anti-electron, which is positive charge, or electron donate, because when we donate electron, so we have excess of positive charge, so it behave as a negative charge. Okay, the mass remains same for anti-electron, but suppose electron have a negative charge, so the mass of electron is remains same, that is 9.1 into 10 to the power minus 31 kilogram. Okay, and that is also known as positron. Or what is a positron? Positron, a particle which have a positive charge, is positive, but mass of a positron is same. Okay, is this clear, everyone? So charge here, the charge is going to be, if I'm talking about charge, it is going to be -1 of E, or it is going to be positive 1. Nothing is going to be changed other than this. Obviously, one more thing, spin here is going to be negative of half, means anti-clockwise, or spin here is going to be positive of half, clockwise. For clockwise thing, we take a positive sign. For anti-clockwise, we take a negative sign. That is the meaning of this. So this is all about electron. But what we are discussing here, we are discussing photons. So for photon, okay, I am going to write photon completely because P positive is a symbol of proton. So photon have a spin. Photon have a spin S, which is complete one. Okay, means if a photon is rotating around its own axis, so it is completing a one circle like a earth. Is this clear, everyone? Clear na? In properties, sometimes these properties are directly mentioned in the question, and you are going to, you need to select the kind of a particle. For example, the properties of a particle is that is a massless particle and the spin is 1. What particular kind of particle is this? In this way, simplest question: photon, proton, electron, neutron. And then at that matter, you don't know what photon is all about. And then you are going to find, or you are going to take maximum number of times neutron or maybe proton. Clear? So photon is a unit of light, or you can say quantum particle of light. Clear? What we talk about a particle nature of a light, that is photon. And these are the important properties of photon. Is this clear what I am saying? Clear na, everyone? Deliberately I give you this to understand more like what it is going on here. Okay. So now this is photoelectric effect. As we already done this discussion, but in a picturization, as you can see, okay, what it is in general, this is your metal sheet. Every particular metal material is made up of atoms, and then atoms combine to give you a molecule. All general things, we have a charged particle, but the charge is going to be positive charge is going to be equal to the negative charge. Simple as that, and that is the neutral thing, right? If the number of if the number of proton is equal to the number of electron, we have a neutral particle, or you can say we have a neutral thing. We don't feel charge. But in general, any particular kind of a material in which the number of electrons are going to be excess, or if we apply a cell, or if we do some work, here the work is going to be radiation. The radiation can be any particular natural light, or you can say man-made radiation sometimes. Got it now? Because radiation, material doesn't know the difference between the natural sunlight or natural radiation, or it is just required an energy. In any form you can provide the energy. So here we provide the energy in the form of waves, in the form of radiations. So what a photoelectric effect all about? When a metal is exposed to light, light can be any kind of source. A man-made, artificial, or you can say natural. But in general, we talk about natural thing. When a metal is exposed to light, the photoelectric effect occurs, in which the metal emits electron from its valence shell. We already discussed what a valence shell is. The emitted electron is known as a photoelectron. Why it is known as a photoelectron? Because we know radiations, and the quanta of radiation is a photon, right? So you can see that one sense. For example, how many of you play this particular pool game? So in pool game, what happens? There are 8 balls, and you apply a force with the stick on a one ball. That one ball is going to hit the another balls, right? In the same, it is going to be with the carom board also. So in carom board game also we are going to hit the strike with the finger, and that striker is going to be hit another, you can say, coins. Either the you can say the main queen coin, which is the you can say orange, sorry, orange I'm saying, pink or red in color, or either the, you can say, the 20 mark, which is wooden coin, the yellow or the black coin, right? So in a same sense here, instead of directly photon, because photon is what, light, so we hit basically photon in the form of radiation, in the form of light energy. So the same process happened whenever we hit the light. So the material, the metal going to interact, and that energy going to transfer into two ways. First, it is going to evacuate, means this valence shell electron is needed. It's a minimal amount of energy that is fixed for a specific material, so it can become a free. The moment it can become a free, it's going to rotate, and when it is going to rotate, so we make a circuit to get the electricity to make it complete rotation, and the moment it is start rotation continuously, it is going to give us a electricity, and that is the whole soul process. Is this clear, everyone, what I'm saying right now? Tell me, beta, is this clear na? That is the simplest thing, but obviously the properties, the theory, it is going to make a little bit boring sometimes, and sometimes you are going to feel why we just learning this single statement, single line again and again. Is this clear what I'm saying, everyone? Four of you, clear na beta? Okay, so simple thing, as you can see here, light is going to be incident in the form of waves, and this wave can eject this photoelectron, and this ejected photoelectron is going to be travel, and that is this particular whole phenomenon, and this phenomenon is commonly known as photoemission, and the whole process is known as photoelectric effect. Okay, so what is threshold energy for the photoelectric effect? This threshold energy is basically that minimum bare energy, minimum energy to make valence electron free, as simple as that. Okay, and what it is written over here, let's see that. The photons that strikes the metal surface must have enough energy to overcome the attractive force that binds the electron to the nuclei in the order for the photoelectric effect to occur. What does it mean? Okay, again, same thing, same example. Suppose I have this atom, okay, in a material. I pick a unit area, or on this unit area I have so many number of atoms, but I can make my, you can say, contact of this radiation energy on this atom, and this atom have 3-4 electrons in the outermost shell, okay, and suppose 2 electrons in the most outermost shell. In this way you can understand. Just a minute. So obviously whenever any particular light source, whenever any particular light source is going to hit, okay, in this way. So if that particular light source doesn't have that threshold energy, so these electrons, these outer shell or valence electrons, are not going to free, and they are not going to eject. If they are not going to eject, so the minimum bare condition, the necessity condition for photoelectric effect is not going to fulfill, and we cannot see the any particular kind of effect. Is this clear, everyone? So the same thing is written over here. The photons means, yeah, thank you. The photons that strike the material, these photons, obviously these are minute particles in the form of a wave, right? So these photons need to have this minimum bare energy. Clear? Okay, so it can overcome this thing. What is the thing? This is your nucleus, and we know nucleus having a proton and a neutral charge, so it is a positive thing, and this one is your electrons, to overcome this attractive force in between the opposite charges. So the threshold energy, what it is very important. Okay, sometimes a direct definition you need to write for a 1 mark, for 2 mark thing. The threshold energy represented the symbol phi. is the least amount of energy. Read each particular word a very you can say with the focus. The least amount of energy required to remove an electron. An electron is single electron. Only single electron we are talking right now. From a metal, a photon's frequency must be identical to the threshold frequency in order for it to have the same energy as the threshold energy, which is the minimum frequency of a light required for the photoelectric effect to occur. The corresponding wavelength, called the threshold wavelength, generally denoted the symbol lambda th, which is threshold wavelength, and the threshold frequency is usually denoted by the symbol VTH. Okay, what it is in general, everything what it is going on. How energy is, first of all, E equals to H nu. How it is coming. So as we know, again with the you can say unit H having a symbol, you can say unit joule into second. Clear? If I multiply with this second inverse or 1 by second, because frequency here you can understand frequency have a unit 1 by second. So equating this SI units or equating this dimensions, we can say this is the appropriate formula for energy, isn't it? Because energy joule and Planck constant of a joule into second into 1 by second, that is going to be joule again. Is this clear? So for any particular you can say wave, for any particular radiation, for any particular wave nature, we can represent this E equals to H nu, the amount of energy, the amount of energy these particular waves carry of frequency nu or frequency f. And we know this thing very firmly, very you can say in the early classes, velocity of light c, that is v into lambda. Okay, frequency into lambda, basically frequency into lambda. So if I want to find frequency in terms of lambda, so that is c by lambda. So this equation number 1 can be converted into hc by lambda. Okay, so what it is, this is the ETH. ETH is ETH beta here is threshold energy, and that is phi. Okay, so ETH is phi, so obviously it is going to be HVTH. VTH is the threshold frequency. Here E, that is okay, threshold energy ETH, or I can write here. Okay, here the threshold energy. What is threshold energy? The minimum energy to make an electron you can say ejected, to eject an electron, single electron. Threshold energy. So with a threshold energy ETH, we can represent with the symbol phi, and that is going to be HVTH. VTH here is what it is. It is going to be threshold frequency HC by lambda TH. So here lambda TH and VTH is nothing but these things, usually denoted by the symbol VTH, that is threshold frequency, and lambda TH is what it is, where VTH is nothing but threshold frequency. Okay, and lambda TH is nothing but threshold lambda or wavelength. And what is threshold? LENGTH, the minimum frequency to make an electron eject, to occur, to happen this photoelectric effect. Lambda TH, threshold wavelength, the minimum wavelength, okay, to make an this particular thing, to make an photoelectric effect, FREQUENCY, to make this particular effect in general. Is this clear, everyone? What is this all about? So from single thing, sometimes directly VTH, this lambda TH or ETH you can need to find out. Is this clear, beta? I move ahead. Is this clear, na? This thing, because what it is written and what it is drawn here, the same thing I draw. Clear? So this is all about threshold energy for a photoelectric effect. Now moving ahead, this is the relationship. Yeah. So this is the important, or you can say one of the very, very important equation for photoelectric effect. From this single equation you can solve so many different kinds of numerical. Okay. So what it is, as I already discussed, as we already know, this particular energy of a photon is necessarily more than that the threshold, because we don't want to make just electron eject. We want to make this move also. Unless it is not going to move, so we don't get energy, or we don't get an okay, sorry, we don't get this electric effect. So how we can say photoelectric effect? Because this word is made up of two words. In general, photo means photon, electric means electricity. Whenever a photon is going to hit, it is going to interact with the metal. So the electron of that particular metal is going to eject first of all. These are known as photoelectrons, and these photoelectrons are going to move also. That is how, that is why, and then only we can get the electric effect or electricity, right? So that is all about this photoelectric effect. So threshold energy for the photoelectric effect we talk about. So photon, energy of a photon is going to be distributed in two ways. So these two ways is nothing but E, directly you can write wave function, or you can say threshold energy, plus E, energy of electron, or sometimes, or not sometimes, it is also known as directly it is W naught plus KE, and that is very, very important equation. You can see this equation again and again in different kinds of books, where W naught is threshold energy, or you can say threshold function of a particular material, and Ke is the kinetic energy of electron, because it is need to move, and the same thing is written over here. As you can see, E is going to be h nu, or this W naught wave work function. In some books that is also known as work function. Work function and this threshold energy is the same thing. What is a work function? Work function is basically the minimum energy, the minimum work this particular photon needs to do to make that electron ejected. As simple as that. Clear, everyone? And that is also this phi, and that is also h nu T h, and that is also hc by lambda T h. In any particular form you can write it down. W naught is a work function, and Ke is basically the kinetic energy of a moving electron, and that is the whole process. Okay, so this equation you can write in this way also: half MeV square, where E photon signifies the incident photon's energy, which is equal to h nu. Phi signifies the metal surface threshold energy, which is equal to this, also known as work function. Okay, also known as work function. E electron is the photoelectron's kinetic energy. That is not simple electron. That is basically the photoelectrons, which are only and only ejected or evacuated from the valence shell after getting this energy. Okay, so this is basically kinetic energy of a photoelectrons. So you can rewrite this thing in this way also, like energy is work function plus Ke, and this Ke is the kinetic energy. Not this color. Choosing color is the most problematic thing for me. Work function of a material, work function for material, or you can say of a material, of a metal or material. Okay, and this Ke is basically kinetic energy, kinetic energy for photoelectrons, for photoelectrons. Okay, both are color look like same, so I can rewrite this thing with some dark color, and that is I can use this. Not this. Yeah. Clear? So where W naught work function, also known as a threshold energy, the minimum energy, or the minimum work you need to require, you need to done to make an electron ejected. Simple as that. Is this clear? I don't think so. I need to write the whole soul definition of this W naught. Work function you can correlate. Clear na everyone, beta? Okay. So the minimum condition for photoelectric effect, we are going to talk in the next pages. And then what is this work function? Already there is work function of threshold energy. And then minimum condition, then equation for this. And then this. So much theory in this class. Okay. So moving ahead, this is your minimum condition for photoelectric effect. That is the necessity condition. You can write it also. Minimum or necessarily necessary conditions. Okay. So threshold frequency. I don't know why this is written over YTH. Okay, maybe they want to write this symbol, and so you need to bear this, beta, because I can't bear this, but you need to, because sometimes math type and this they don't understand the SME, so they changes few symbols. Okay, so this YTH here is basically this frequency. Got it, everyone? And this Y is basically the normal frequency. Is this clear now for you guys? Bear with me. I'm also seeing this because I cannot change everything. So threshold frequency, this YTH, the threshold frequency for the metal, is the lowest frequency of an incident light or radiation that will generate a photoelectric effect, that is ejection of photoelectrons from a metal surface. It is constant for one metal. That is important line. It is not, if you pick any particular metal, right? So that is going to be fixed. It is not going to change. For example, if we pick aluminium, so the threshold frequency for aluminium is going to be, suppose 1404 into 10 to the power minus 7 hertz. So it is going to be fixed. You cannot see that after a certain time it is going to change. Obviously, after certain condition it is going to be changed if you're going to heat it up. Why? So if you're going to heat it up, so you already provide a little bit amount of energy from the another sources, from another methods. Got it? But in normal condition, in STP, what is STP? Standard temperature pressure. It is not going to change until unless we are not going to do something which is going to give another form of energy to it. Got it, beta? So that is fixed. So it is constant for one metal, but various metals have varying values. Obviously, that is fixed. That is quite obvious. Another different materials have different YTH, which is threshold frequency. If Y, frequency of incident photon, and YTH, threshold frequency, then if this is going to be, so obviously photo electron ejection is not, obviously your photo electron is not going to be eject, and the photoelectric effect is not going to be visualized. So that is again important. Okay, if this frequency is going to be lambda DH, photo electrons are simply expelled from the metal surface, and the electron's kinetic energy is 0. It is going to be equal then. Means if the given frequency of a photon is almost equal to the threshold frequency, so ejection of electrons or the production of photoelectrons is going to be done, but these electrons doesn't going to be moved. Why? So because the incident photon doesn't have frequency more than the threshold frequency. Clear na? Okay, in simple sense you can understand in this way. For example, if any if any particular product you like, and that product have a you can say a cost price or CP 10 rupees, and you give to the shopkeeper, you give 15 rupees to the shopkeeper. So then only shopkeeper returns you 5 rupees in back, right? If you only give 10 rupees, so that particular shopkeeper doesn't be going to give you anything in the back, or you can say as a rupees. But if you try to purchase that particular product in 8 rupees or 7 rupees, so it is not going to be. Shopkeeper is going to say you, but means go away. So in this way, this simple thing can be correlate the same sense. If the sorry, what I'm doing. If the incident frequency is only and only equal to the threshold frequency, so the projection of electron is going to be obviously, but kinetic energy is going to be zero. If the incident frequency is lesser than this threshold frequency, so neither the ejection of electron is going to be done, or obviously if the ejection of photoelectron is not and the photoelectrons are absent, so the movement is never ever a case. And the third case is important one, when this frequency is greater than this lambda t frequency of threshold, so the photoelectrons is going to be ejected as well as, and the kinetic energy will be ejected from the surface is more than the zero. As simple as that. Okay, clear now everyone? So moving ahead in the terminology, this is the same thing. I'm not going to rewrite, I'm not going to even tell you what it is happening here. The same thing is going to be happen for this lambda th, but the condition is going to be changed because lambda is inversely proportional. So if lambda is lesser than, so obviously energy is going to be more, and energy is going to be more means the production of photoelectrons is going to be done, and the motion of photoelectron is going to be done. If it is equal, so only production is going to be done, and if it is greater, so energy is going to be lesser. Why I'm saying this? This is inversely. Energy is hc by lambda. If lambda high, okay, just a minute, beta. If which one I choose? If lambda is high, energy is lower. Okay, the second case. If lambda is lower, so energy is high, and that is what we can see. If the incident photon have lesser wavelength to the threshold wavelength, so the photoelectric effect will occur, and the expelled electron will have kinetic energy. If it is almost equal, the photoelectric effect will be the only one that occurs, and kinetic energy of the ejected photoelectrons will be zero. For the third case, what it is? Yeah, for the third case, there will be no photoelectric effect. Why so? Lambda greater, energy lesser. Energy lesser, we cannot see the photoelectric effect. Is this clear, everyone? Is this clear now, beta? Okay. Good. So this is again the work function. As I already discussed, what is the work function? Work function or threshold energy, that is symbol phi or W naught sometimes. The work function threshold energy is the minimum amount of thermodynamic work. Thermodynamic means heat kind of work required to remove an electron from a conductor to a location in vacuum just outside the conductor surface. Okay. What does it states? Suppose there is a vacuum chamber. In that is the setup basically. In this vacuum chamber, you put a plate over there, and obviously light cannot. Light energy is going to be transmitted through vacuum chamber even, and this is your light. Okay, so from there, this simple electrons going to be ejected due to this. Why we make a vacuum chamber? That is the separate one, you can say separate interesting story. But let's suppose we are going to see this. So obviously these are going to move. Clear? And that is all about. And what we are going to do for this, the story is not end here, story is begin here. We are going to make a wire. Okay, we are going to use as the wire. We are going to give this a little bit more. What is a little bit more? We are going to apply a battery also. With this circuit, we can get a current. Clear? Okay, I can. Yeah. Now you can understand. Negative, positive, negative, positive, negative. Your battery of potential V, and obviously electron is going to be this is positive now, so I need to make it positive look like, yeah, positive, negative. So these electrons are trying to passes through this, and then it is going to come back, and again the circuit is going to complete. So this is the property, and this is what about this thing, which is photoelectric effect. Is this clear, everyone? So remove an electron, I mean thermodynamic work required to remove an electron from a conductor to a location in the vacuum just outside the conductor surface. This is your conductor, and that's just outside the conductor surface. So this or threshold energy is nothing but H into YTH, which is frequency of threshold, and Hc by lambda. If E energy of an incident photon, then I mean if it is greater than, so then what we are going to see, the next condition, the same thing condition is written over here. Okay, so this is all about your this thing. If E is this case, okay, can someone please tell me why we need vacuum? Why? Because you don't ask, so I ask, why vacuum chamber is necessary? Tell me, anyone. Why vacuum chamber is necessary? This vacuum chamber, why should I make it? Anyone? Obviously, you are four today. Pavan, Shakti, Yajira, and this Vishwanath. Okay. Akash Kanna or Akash Kanan. Are you there? Or you are in the lobby all together only? Why vacuum chamber is necessary? Someone please tell me the answer. If you know, and if you don't know, so then why don't you ask? And if you don't ask, so why don't you I mean bother about it? What are you doing, Shakti? What are you writing? Very rigorously. Keep writing, keep writing. What are you doing? I ask one simple question. Why vacuum chamber is necessary? In photoelectric effect, basically. If you are listening what I'm saying since last 10-15 minutes. Anyone? Simple basic logic. Common sense. So what is that common sense? Tell me. Tell me anyone. Yajira, Shakti, or this Pavan Aditya beta. Sir, maybe understand the motion collision of particle. But obviously collision of particle is going to be done all together. Why there is vacuum chamber? That is very common. Whenever any particular charge particle is moving from one part to another part, so it radiates its energy, right? Release its energy. And if it is releasing its energy in the air, O2, so everything is going to be burst. Why so? Because to catch a fire, oxygen is required. You cannot make a fire in the oxygen, in the absence of oxygen. And you can do that, glow a candle, okay, or blow a candle and put, you can say, glass of water, steel glass on that. After a few seconds, even it is going to stop. I mean, if it is going to, I mean, not glow up, or it is going to be not burn. The burning condition of this candle is going to be stopped. Why so? because the moment all oxygen particle is going to be burned, the energy, this light is not going to be blown, because that any particular fire, any particular this thing is necessarily required oxygen to burn. Burning effect require oxygen. So your candle is not going to burn more if the oxygen is not there. So the same sense we see, and the same sense we connect a wire. Why we connect a wire? Because these electrons can transfer through the wire, and when it is just coming out from a metal, because the metal is here, this, isn't it? This is my metal, na? Which the right? Yeah, this is my metal. So if any electron is just coming out of the metal and it is going to be moved in the air, so it can catch fire, or basically it is going to release energy, radiate energy. So the first thing you can see a spark if it is happening in the air. Got it, everyone? So when I say something, ask me out. Participate at least here. Don't listen me only. I'm not always right. Cross verify that, sir, why it is happening. Got it now? If it is written over here, remove an electron from a conductor to a location in the vacuum just outside the conductor surface. Why? Why this vacuum is necessary? At least ask why. How many of you have vacuum chamber in your home? Tell me. So have you thought about why you don't have vacuum chamber? Because to create a vacuum, it is a much expensive thing. So why we need, why we spend our money on this? Okay, if it is expensive, obviously it is expensive, but to make this whole experiment done, we require this creation of vacuum. Is this clear, everyone? Clear now? Good. And that is why each particular labs, hospital, and where you can see subatomic particles or even the small insects going to be give a large impact or create a large impact, we have vacuum cleaner there to clean all the surface very precisely. Clear? So this is again the condition in the form of energy or work function. So if E lesser than work function, there will be no photoelectric effect. If E just equal to the work function, okay, you can rewrite as a symbol as a W as a work function or threshold energy, whatever the thing you wanted to understand or write. Or threshold energy. Okay. Now I change color. Yeah. So if E is just equal to the phi, the photoelectric effect occurs, but the kinetic energy of the expelled photoelectron is 0. If E is greater than 0, obviously the photoelectron phi is the missing here. If E is greater than phi, the photoelectrons or photoelectron will be lesser than it is going to be, or maybe this is going to be repeated. So just remove this one. And this is your third point. If E is greater than the work function or threshold energy, the photoelectric effect will occur, as will the expelled electrons possession of the kinetic energy. Means the kinetic energy is not going to be 0 even. Now this is the equation of photoelectric effect, and that is again important. We just rewriting this. Okay, we just rewriting E equals to H nu equals to work function plus KE into this form, where KE is nothing but H nu minus work function. This is the same equation, right? This one, isn't it? So KE max means the maximum kinetic energy for any particular photon or photoelectron is not photon, photoelectron is H nu minus work function, because work function is fixed for every material. So KE max is the maximum kinetic energy, right? Maximum kinetic energy of a photoelectron, H nu is the energy of a photoelectron, phi is the work function of the material. Clear everyone? Okay, you can rewrite this K max into the terminology of P, or momentum of a P square by 2m. Here Me is the photoelectron, mass of a photoelectron, and P square is basically the momentum of a photoelectron. Not photon, photoelectron. Okay, or simply 1 by half m square is the simplest thing. And P by C, photon is also represented as we uh, learn this particular concept in the beginning. Photon of this, I mean momentum of a, that is related for a photon, right? Not for electron. Okay, so just stick to this. Now we can take a break. I need a break, and then I'm going to this, I mean, explain you more what it is happening here. And the next slide is going to be important. But the main thing you already done. Now the graph with the the graph with the photoelectron with the frequency, or you can say the graph of intensity with this this you can say retarding potential, or you can say basically the threshold potential and photocurrent we are going to see. Okay, and then the stopping potential and frequency. Okay, so the main thing of this lecture we done all together. The important graphs are still remaining, so stay there, and we are going to take a break for 5 to 10 minutes, not more than that. Okay beta, we are going to meet just after 5 to 10 minutes. Hello, hello, hello. Am I audible? And I am going to be visible now also. Okay, so let's finish this within time. And see, we almost done the important thing. The you can say other important things just about the graphs and how it is going to be represent. But you need to stick to this equation and the main equation of this. This is your photoelectric equation, and this is your kinetic energy or maximum kinetic energy for photoelectron equation. So these two equations you need to stick. Everything is going to be dependent on these two things. Clear, everyone? So moving ahead, this is what photoelectric V2 V1. So what it is in general, this is the collector plate potential anode, and this is the retarding potential. Means if the photoelectric, uh, I mean the incident photons are going to be this much of potential. So obviously it is going to give you this effect, or it is going to give you this particular ejection of photoelectrons is basically this represented. But if the electron, I mean if this particular photon have energy very lesser than this particular wave function, means if this is the limit of your phi, okay, what is phi? Work function, W naught, and your potential is going to be here somewhere below, then I mean behind this thing, just a minute, behind this thing, okay, and your incident photon is going to be potential here. So ejection of electron to see. So what this graph states about it, even if we have a V3, V2, V1 in the negative sense, means this retarding potential is going to be V3 is the potential of this particular photoelectron is greater in the negative sense. But after certain or after reaching to a point, each particular photoelectron, each particular ejected photoelectron, this one and this one, each photoelectron, or you can say each ejected photoelectron reaching to a reaching to a saturated current, or reaching to a saturation of a current. Is this clear, everyone? Clear na? Means once any particular metal gives you a photoelectron, or once the ejection of a photoelectron is going to be done, so obviously the motion is going to be equally distributed, and the photoelectric current or the saturation of current is going to be visualized after a certain amount of time. Is this clear, everyone? Is this clear, beta, everyone, or not? So this graph states about this. Clear? Good. Moving ahead, this is the same thing, and just neglect this thing. I mean, same slide. Okay. Yeah. So this is your one of the important, you can say, Hals and Leonard studied photoelectric emission in depth, and this is the experimental setup we are going to see in the next slide. So basically, whatever we learn theoretical wise, we are going to see the experimental setup and the experimental proven also. And the experimental proven is done by these two scientists. That is your the name of a scientist, Hal. I don't know, Leonard did the deepest, or you can say, on the experimental setup, the studies. So what they did, Heinrich Hertz discovered the phenomenon of photoelectric emission in 1887. He noticed that when the spark gap is open, it conducts electricity more easily. The ultraviolet light from the arc lamp illuminates the emitter. Okay, what does it mean? Means when there is a small gap is going to be in between the two light sources. So what happens when this small gap is going to be? So the spark is going to generate in the process of this ignition. Okay, and this UV light from the arc lamp illuminates. Means emitter is going to be basically the emitter, collector, and this you're going to learn. But there is a, you can say, a semiconductor kind of device which is going to be give you the light energy from the electric energy, and you get the in the same you get in a reverse case also. So during the years of 1886 and in 1902, these two scientists did the, you can say, depth study in the photoelectric emission when ultraviolet radiation is permitted to fall on the emitter plate of an evacuated glass tube. Evacuated glass tube means vacuum chamber, or two electrode, I mean evacuated glass tube containing two electrodes. Current flow through the circuit. According to Leonard, the current flow stopped as soon as the UV radiation were turned off. Means the moment, the manner we turn off the UV radiation, basically the radiations and basically the light. These findings suggested that the ultraviolet light strikes the emitter plate, electrons are expelled from it, and the electric field attracts them to be positive collecting plate. And due to this anode cathode, there is a production of electric current is going to be generated with the help of with the help of this radiation, with the help of this UV rays. And this is all about the experimental setup, and that is all about the experimental proven of a photoelectric effect, what we're going to see in the next page. So that is your, you can say, evacuated glass tube, or basically the vacuum chamber, what I talk about in previous slides. Okay, evacuated glass tube means this is entirely a vacuum inside. So when a light source is going to be hit on this particular surface or a cathode surface, so from the cathode the electrons is going to be repel, and these electrons is going to be attracted towards the positive side. It is going to be attracted, it is not visible. Okay, it is going to be attracted towards the positive side. This is cathode, this is anode, and this is experimental thing. And through this potential and through this emitter, basically this one is emitter, okay, we can deduct a micro current, obviously a very small amount of current, but we can deduct. Okay, is this clear? And this is the circuit, and what it is a rheostat, changeable resistance. Variable resistor. Clear, everyone? So this is the experimental study of photoelectric effect, important one. Obviously you are not going to get numerical questions from there, but for the understanding part it is going to be important. Is this clear, everyone? Clear na? Okay, so whatever it consists and whatever the requirements, we can go for it. Experimental study of photoelectric effect, it consists evacuated glass tube, photosensitive plate C, metal plate A, light source S, monochromatic light, monochromatic again, single frequency light. Not this. Single frequency. Single frequency light, monochromatic. Okay. Quartz window W. Monochromatic light from the source of sufficiently short wavelength enters the tube. Okay, enters the tube through the quartz window and falls on the photosensitive plate C, which acts as an emitter. Emitter means which is going to emit the electron. Here the emitter is pronunciate, and the meaning of emitter means emit the electron. The electrons are emitted by the plate C and are collected by the plate A, collector. The electric field is created by the battery. This battery creates the electric field, and that is C, the emitter, and that is A, the acceptor or the collector plate. Is this clear, everyone? Is this clear, beta, everyone? Okay. Now important observation, what we observe from the experimental study of photoelectric effect. So these are the important things. When light is incident on emitter plate, the photoelectrons are emitted. The photoelectrons are attracted by a positive plate. The emission of electrons causes flow of electric current in the circuit. The potential difference between the emitter and the collector plate is measured by the voltmeter, whereas the photo current or photoelectric current, which is a minute current, we can say very minimum amount of current is going to be produced. Following the circuit is measured by the micrometer. Micrometer, basically the symbol is wrong here. As you know, micro means 10 to the power minus 6. Very limited, very minimum bare current you are going to observe. Okay, why so? Because 1 microcurrent is nothing but 10 to the power minus 6. Ampere. We are talking about ampere, not ammeter. Okay, so that is whole soul the story. We already know, but in a proper written manner, whatever we observe from the experimental concept, whatever we get from the experimental sense, experimental, you can say, setup, these are the important points. If you get a, you can get this all if you are lucky enough, first thing. And the second thing, if you get a theoretical question for 4 or 3 marks, or you can say for 3 marks, subjective question, write the experimental set about the important observation you can get. So if you write in this manner, so also 3 marks is going to be given to you in boards. So that is for board wise, that is going to be important. Okay. And 2 mark question is going to be related to find the maximum kinetic energy of a photoelectron. That is K max equals to h nu minus work function. As simple as that. Clear, everyone? How many times I need to say this? Open your camera. Open your camera. Why are you behaving like a 2 or second or third class student? Tell me. Do you need a speech or do you need a motivation and talk and something like this in each particular lecture? Huh? Am I teaching to a wall? You are only 4, first of all. And then you are doing this. Seriously? I can finish this in next 10 minutes, beta. Don't make me to do that. Experimental study of photoelectric. Obviously, this particular topic is going to be more theoretical. You never ever ask anything. Second thing, I am teaching to a black window. Okay. I know from one single equation is going to be, but the experimental thing is necessary because you need to give the board examination as well. And if you want just a numerical thing you need, so let me know. I can shrink it down and I can cover your syllabus within the month of November, Diwali. Because the next all lectures, believe me, all I'm saying, next all lecture is going to be a bit boring, a bit theoretical, less numericals, more theory. But that is the important thing, and that is, you can say, one important aspect. You can score good in both of ways, in boards, in your CBSE 12th boards exam, as well as in your JEE mains, because these questions are going to be bit theoretical, either in MCQ, either in assertion region, either in you can say match the box thing. But you get only clarity in the whole soul concept only and only if you are focused enough throughout the chapter. One single statement can be asked in 3 or 4 times, and that is why we are teaching you different. Why should I teach you on the basis of energy, on the basis of lambda, on the basis of frequency, on the basis of experimental setup? Am I dumb enough? Tell me. Because being a student, I can think the same way like you are thinking. Sir, only single equation, only single phenomenon. Why you are taking 2 hours lecture for this? Because that is required, beta. We give you only 3 lecture for this chapter. 3 lecture. If you are going to learn, if you are going to read line by line from the NCERT book, so you take at least 4 days. And then even you are not going to understand what is written over there. Got it? So try to be with me at least. I feel more bored to teach you this again and again, single statement. Got it, na? Being a teacher, I don't enjoy this thing. Teaching a single line again and again in different way. But that is the way. That is how the examiner asks. Sometimes on the basis of kinetic energy, sometimes on the basis of frequency, sometimes on the basis of work function, sometimes on the basis of whole soul theory. What is a photon? If I'm going to ask 5 properties of photons from you right now, and I'm sure 100% no one is going to tell me without seeing whatever you write. Got it? And we are in between the lecture. So suppose you done whole chapter, whole second book, and then I'm asking, beta, tell me what is a photon, and is of half of marks, 3-mark question, write 6 properties of photons. So first of all, you are thinking what is a photon itself. The second property is all about. Okay. Where I was, yeah. Experimental study of photoelectric effect. The potential difference applied between the plates can be changed by the potential divider arrangement. We arrange a potential divider. What is a potential divider? The variable resistance can change the potential. Okay. By means of a commutator key, plate A can be maintained at a desired positive or negative potential with respect to plate C. Okay. With this setup, as you can, Yeah, with this setup, I can change the potential of this plate. The manner, the moment I can change the variable resistance or this potential. So it is in my hand. Okay. Now this is the important graph. Okay. This is the important graph in between the photoelectric current and frequency. What it is? It is your work function. And what it is? V naught, threshold frequency. Obviously, if I'm going to ask na, beta, you don't know what it is. Threshold frequency. So the simple same equation is going to be fulfilled. RQUENC. So this is your means the minimum bare amount of work which you need to do to make an ejection of electron. And when the ejection of electron is going to be, so it is going to be exponentially increase its speed, and after certain time it is going to move with a constant speed, and that is all the same graph is all about, isn't it? Clear na? So that is all about, that particular graph we can get from the experimental setup even. So collector plate A is given an appropriate amount of positive potential. The frequency of incident light is gradually increased. Okay, it is increases from 0. It is obviously 0, little bit. This is your V naught, a minimum threshold frequency from where the ejection of photoelectron is going to be done. So increase from its small value while the intensity of incident radiation remains constant. The frequency is a property of emitter plate C's material. Okay, plate C and a material known as the threshold frequency for that metal, and it is denoted by V naught. Clear, beta? What we read in the theory, we can observe same thing from this experimental setup as a graph also. The same thing is written over here. So I'm not going to redraw again. The collector plate A is kept at a positive potential in relation to the emitter plate C, attracting electrons emitted from C to A. The intensity of light is modified while the frequency and accelerating potential remains constant. The resulting photoelectric current is monitored. Means you can change the particular intensity of light while making the current constant, because intensity and current is not going to be, once you provide much intensity which is more than that of this particular thing, the function, then the photoelectrons is going to be ejected, it is going to be generated, it is going to be you can say product, and then all whole soul energy is going to be converted to make the motion of electron, and the motion of electron is not going to overshoot. Overshoot means they are not going to move with a higher speed, and so you are getting bare kinetic energy or you are getting more electric current. After a certain time, the what I'm saying, the intensity is obviously is directly proportional to energy, and it is directly proportional to the number of photons, or basically E equals to h nu. So intensity I is directly proportional to nu, not mu. Mu is frequency here, but photoelectric current is not. Why so? Because Ke max is E minus phi naught. So it is going to be dependent obviously on this, but once it is start moving, so after a certain time it is going to be constant. So that is it, written over here. Clear? Means the intensity of light is modified. As you can read it, value of incident radiation and accelerating potential remains constant. Accelerating potential means this potential and this radiation remains constant, and thus the resulting photoelectric current is monitored. Monitored means you can check what it is, and that is your effect. As you can see, this is your photoelectric, and meanwhile it is going to give the different intensity, that is I1, I2, I3. Clear? Means once your electron is ejected, this is your this work function again. So meanwhile, increasing this photoelectric current, it is going to be give the more if you provide more energy, because then Ke max is going to be more. Is this clear, everyone? Okay, so now this is your equation. I mean, how your this particular K max is dependent on the potential. So the energy of all photo, and that is very, very important again, this single equation. So yeah, the energy of all photoelectrons released from a metal surface is not the same when the stopping potential is adequate to reject even the most energetic photoelectrons with the highest kinetic energy. The photoelectric current becomes zero, and half mv square max is ev naught, where v max is the maximum velocity of photoelectron, m is the mass of the electron, and e is the magnitude of charge of the electron, where v naught is the potential. Okay, so this is the important relation between the Ke max, and that is v naught is not here, it is potential. Here v naught is not the work function or threshold, it is stopping potential. Okay, what does it mean? It is going to stop this particular thing to make more and more amount of motion. Clear? Means what it is, again I am saying that if you have any doubt, question, query, you can ask me. Stopping potential is that particular potential after that the photoelectron cannot get more you can say kinetic energy, or the that it cannot overshoot the maximum limit of velocity. It is equal to that, and that v naught stopping potential we can apply in the system. Clear? Is this clear with everyone? And that is why the word itself states that stopping potential. And due to this stopping potential, the saturation of current we can see, because we have a this tendency in our hand to get the maximum kinetic energy fixed. Is this clear, beta? And Ke max or this V naught is basically stopping potential can be different for the different material. Why so? Because Ke max, which is EV naught, is nothing but E minus work function, isn't it? So this stopping potential can be differ for a different metal, and we are going to see in the next slide. So this is the same equation. for different stopping potential, you can see that the current is going to be saturated after a some time. Why so? Because even if it is different, but this after a certain time, the kinetic energy is going to be fixed. When once we give this E equals to h nu, that is phi naught, or you can say phi plus ke. Okay, so saturation is going to be done. So effect of potential difference on photoelectric current, variation of photoelectric current with the collector plate potential for different frequencies of incident radiation. Means if you provide lesser amount of stopping potential, so this give you this particular kinetic energy more, but after reaching to a certain point, it is going to be fixed, saturate. For this, it follow the different path, but it is going to be fixed as well, and it follow a different path, it is going to be fixed as well. Clear na? So that is all about this graph. And the graph variation of stopping potential with the frequency of incident radiation is this. This is your frequency for material A. Okay, I can write frequency of material A. Yeah. Now this is fine, and this is the frequency of material B. So obviously, as you can see, till this point the work function, and then it is going to overshoot work function for A. And I can change the color first of all. This is till this the work function of A, and that is going to directly proportional to this, whatever the stopping potential. And in the same sense, this is the work function of B, and then it is going to be this. Clear? Okay, so theory wise we also done. I think this is your first question. Do that and tell me the answer. Okay. For a photosensitive surface, the work function is this. Find the threshold frequency. Very easy. Work function is given. You need to find the threshold frequency. I don't think so. Easier than this is going to be something. Okay, meanwhile I can watch your this. Where are you guys? Are you? Hey, what about others? Shakti or this Yajira and I think Akash Khanan. Do you get answer A also or something else? It is very easy. Work function W, that is 3.3 into 10 to the power minus 19 joule, and that is what we need to find frequency na. So H nu naught, you need to find this. So nu naught beta is nothing but work function upon H. So 3.3 divided by 6.6, that is 1.2, which is 0.5, and that is 5 into 10 to the power same. Explanation I don't think what I mean, why, to make a more clarification. This is this, you know this thing. Okay, this is the same page, and this is the equation. So that is the correct answer you see. Clear? That is the next question. The stopping potential for a photoelectric emission process is 10 volt. Find the maximum kinetic energy of the electrons ejected in this process. Go for it. Very easy again. What is this answer? I mean, what is the answer of this? That is very easy, beta. See, exactly. You don't need to do anything, just multiply with this E. E max EVS or EV naught. That is going to be 1.6 into 10 to the power minus 19 into 10, that is 1.6 into 10 to the power minus 18 joules. So each energy have the unit same joule. What is this E, beta? Even after writing that much you need, I ask why. 1.6 charge on an electron, E. Is this clear now? This one. Is this clear? Pavan, beta you. Okay. So in this way we finish this particular lecture, and this is the summary. We done the introduction of P effect, electron emission, Hertz, learned Leonard observation, and experimental setup for photoelectric effect.